Alright guys, let's take a look at today's assignment doing synthesis and decomp reactions. You will need to have p-table pulled up, so I have mine here in this tab, just because we are going to do some, we had to figure out the formulas of an ionic compound, so we got to make sure we have our charges right, so you just want to have access to p-table. And now there are a few slides here. I'm going to do the first slide with you guys. There's a synthesis and a decomp on each one. So I'll do this one, which looks almost exactly like your third one. So this one will serve as an example for this last slide. And then this middle slide right here is just asking you to show a synthesis and a decomp reaction using these little symbols. So remember, synthesis, you are using two elements on the left-hand side to make a compound, and then in decomp you're going to have a compound on the left and then two elements on the right. So you're just going to depict that here. The square and the circle are going to be your elements, and then the square circled together is going to be your compound. Okay, and then you have a little plus symbol here, so you can have them on each side. And that's just a visual representation. And again, I'll do an example that will help you with this slide right here. Okay, so we've come to the point in this class where you guys have a lot of knowledge that is going to be applied here in these examples. Okay, so you have knowledge of naming ionic and covalent compounds. You have knowledge of finding the formulas of ionic and covalent compounds, and then also you have knowledge of balancing chemical reactions, and we're going to have to do all of that here. Okay, so here we have our two formulas, or our two chemical reactions that we have to figure out. One is synthesis and one is decomp. Okay, so the first thing I'm going to do is classify my reaction as synthesis or decomp, so I know what I'm doing. Well, here I have nickel 3 oxide, and it's going to yield something plus something else. Okay, I know that this is going to be a decomposition reaction because we're starting with a compound, because nickel 3 oxide is an ionic compound. And I see I have two things on my right hand side, so this is showing me that this compound is breaking down into two smaller either elements or compounds. Now, for us and our purposes, we're only going to be doing elements. Okay, so your decompositions will decompose into elements. Okay, well, the first thing I'm going to do is figure out what are these elements decomposing into. Well, I have nickel oxide. So I know in this compound I'm going to have nickel and oxygen, because remember, if we change the ending back to the original formula or the original name, it would be oxygen. So here we're going to have nickel. So we're just going to type in nickel and oxygen. Okay, and that's it. So we have nickel and oxygen. Now we have to figure out the formula for each of these things. Okay, so first off, we have our nickel 3 oxide. So we know that our nickel is going to be Ni. Let me go ahead and annotate this really quickly. So we know we're going to have Ni. And we know the charge of the nickel is going to be 3 plus. And then we have oxide here, which is just oxygen. And if we take a look at our periodic table, and I'm not going to do it because it'll eliminate my drawing, but oxygen is in group 16, so then he'll have a 2 minus charge. Okay, now we're going to have to swap, drop, and chop. So swap, drop, chop. So that would give us Ni2O3. And I apologize that I'm not the best annotator with drawing on the screen. So we have Ni2O3 for nickel 3 oxide. That's the formula for nickel 3 oxide. That's where your knowledge from our last unit comes in, right? We have to know how to make our ionic formulas from a name. So I'm just going to go ahead and type this here. So we've got Ni2O3. Now let's do the right-hand side. So nickel is a metal, so he can exist on his own, so we'll just put nickel. Now oxygen. Oxygen is one of your 7 diatomic molecules. Remember in your lecture video I said you have to remember the 7 diatomics, because here is an instance where you have oxygen by itself, but we have to know that oxygen never exists just as oxygen. It exists as a diatomic molecule. So we have to know we need to put a 2 right there. Okay? So we have Ni2O3 and then we have O2. Okay? Now let's balance this equation. So this is down here to help us balance. So we're starting with 2 nickel, 3 oxygen, 2 nickel, 2 oxygen. Okay? So here we've got 2 oxygen, 3 oxygen, and right off the bat I know I'm going to have to find a common factor for our oxygen because we've got 3 on the left and 2 on the right. So I'm going to go ahead and multiply my nickel 3 oxide by 2. Okay. So now this is going to give me 4 nickel, and here I'm just balancing the equation, and 6 oxygen. Okay, so now I have 4 nitrogen and 6 oxygen on my left, and I'm going to balance that out. Well, the way to do that, if I need 4 nickel, oh, I put 2 over here. I actually just had 1. Oops. Let me undo that really quick. I originally started with 1. So if we have 4 nickel on the left and we have 1 nickel on the right, we'll have 4 nickel on the right. 4 times that imaginary 1 is 4. And then for our oxygen, if we have 6 oxygen on the left and 2 on the right, we can multiply this guy by 3, give him a coefficient of 3. Remember, we can only change coefficients, not subscripts, which will give us 6. Okay? And there is our balanced equation. So 2 nickel oxide will yield 4 nickel plus 3 O2, which is oxygen gas. Okay, so that is that decomposition reaction. So you're going to have to figure out the products, predict the products, figure out the formulas of the compounds, make sure we're paying attention to our diatomic molecules, and then at the end, make sure that we are balancing. Okay, let's do one more. So we have magnesium plus nitrogen will yield something. So this was decomp. This one's going to be synthesis, because remember in synthesis you have 2 elements that will yield a compound. Okay, so this is a ionic bond because magnesium is a metal, nitrogen is a nonmetal. So we're going to have magnesium nitride here. Because remember, we write the name of the metal first, then the nonmetal, and we change the ending to IDE. Okay, now so we have magnesium on the left. So on the left we're just going to do our elemental symbols. Nitrogen, hello, though, is a diatomic molecule. It's one of the 7. Remember I said you needed to have those diatomics in front of you when we do these examples. So we know we're going to have N2 because nitrogen never exists by himself. And then we have to figure out magnesium nitride. So let's take a look at our periodic table. Magnesium is in group 2. He's a 2+. Nitrogen is in group 15. He's a 3-. So let's go back. So we have Mg 2+ and N 3-. And then we're going to swap, drop, and chop. And that's going to be Mg3 N2. Ooh. Okay, perfect. So now I'm going to just write it. Mg3N2. Perfect. So now we have our equation, we just have to balance. So on our left-hand side, we've got 1 magnesium, 2 nitrogen, because he's diatomic, 3 magnesium, and 2 nitrogen. Okay, so right off the bat, I can tell my nitrogens are already balanced, which is awesome. We only have to balance our magnesium here, so we have 3 on the left and 3 on the right, or we have 1 on the left, excuse me, and 3 on the right. We want to get to 3 on the left, so we can do that by just adding a 3 coefficient here. Okay, so 3 magnesium plus, you can leave these blanks because they're assumed, or, you know, if it helps you, we can put a 1 right here. Okay, so that is, again, your synthesis reaction for magnesium plus nitrogen. Okay, so again, on the top, first thing you're going to do, figure out, is it decomp or is it synthesis? Then you have to figure out what it decomposes or creates. If it's decomposing, you're just basically identifying the elements that are in the compound. If it is a synthesis, you just have to do your swap, drop, and chop, because it's probably going to be ionic, okay? Because ionic is the easiest thing for you guys to do, where you do your swap, drop, and chop, where you get your charges from the table. Then you want to figure out the compound. So again, swap, drop, and chop for your compounds here. For the individual elements, make sure, double check that they're not diatomic. So remember those diatomic elements that you have, your oxygen, hydrogen, iodine, nitrogen, all of those exist diatomically. So you want to identify if there are any of those in your equation. So like we have oxygen here, nitrogen here, you got to make sure you put the 2 after it. Then once you get your equation, the last thing you're going to do is balance. Okay, and I forgot to change this one here to a 3, but this is balance because we have that coefficient. So this would be 3 now. Okay, so use this as an example to do your slide 4. It's the same thing. You have a decomp on the top, and then you have a synthesis on the bottom. We have iron 2 plus sulfur here. Remember, the iron 2 just gives you a charge, right? So that should be pretty straightforward, but if you have trouble, just let me know.